The year was 1929. Einstein had already proposed his theory of general relativity. Lemaitre, a priest and theoretical physicist, took Einstein's theory in account and proposed that if the theory was to be reality, then everything in the universe must be moving apart. This was then confirmed by observations from Edwin Hubble, who realized that galaxies were moving apart at high speeds. Lemaitre took this evidence and suggested his own idea. If we reverse time, the matter in the universe must be contracting, and so at one point all of the matter must be at a single location in space and time altogether. This was the birth of the Big Bang Theory. Humans have always been concerned about the beginnings of the universe, and this wasn't the first time somebody proposed a theory. There were many flat earth cosmologies which the ancient Egyptians, Greeks, Chinese, Arabs, and Incas developed upon. For them, Earth as a flat model was the most important thing to include, and many different ideas from various tribes were put out. Then there were the geocentric and heliocentric models of the universe, which presented the Earth or the Sun as the center of the universe. Finally, there was the steady state theory, which instead of saying that the universe is expanding with matter moving away, it states that matter is being created as the universe is expanding, keeping the density of matter same everywhere. But this theory is universally rejected as per the observations that the universe is changing and is not in the same state. So, if the Big Bang did occur, one question that may spring to mind is to which corner of space we should be looking in order to see where this explosion happened. And if the universe is expanding, what is it expanding in? Well, in our balloon model, a two-dimensional universe, the Big Bang occurred at the center of the balloon, not on its surface. Space is the surface, the interior is the past, and the exterior the future. The center is the origin of time. So the explosion did not occur in space, but at the beginning of time, and space itself is the product of this temporal singularity. Let us return to the notion that to look far into the distance is to look back into time. Could we actually see the universe evolve? This idea seems interesting. The deeper we look into space, the younger the universe we encounter. Could we then observe the moment the galaxies were born? Yes, if we had the technology. All we need is instruments that allow us to look back through 12 billion light years of space. This technology is already available in the newer, larger telescopes. These instruments can enable us to see when, how, and why galaxies were born. And this is one of the most thrilling areas of contemporary science. Another question that naturally arises is when was time zero and what was there before it? The theory of relativity deduces that the density at time zero must have been infinite. To tackle this situation, we would require a quantum theory of gravitation that does not yet exist formally, and so we cannot offer a scientific treatment of it at this time. Understanding this phase in the history of the universe is one of the greatest unsolved problems in contemporary physics. The Big The Big Bang theory has been confirmed from time to time by various astronomers. Despite the observational evidence in favor of the Big Bang, the viability of the theory remained a bone of contention for quite some time. Various theoretical difficulties hindered the precise description of the observations, until, in 1982, the American physicist Alan Guth proposed a solution that many initially regarded as flight of fancy, the inflationary Big Bang theory. The basic idea behind this theory is that the universe underwent a phase of extraordinary expansion when the universe was only a trillionth of a trillionth of a trillionth of a second old. The universe expanded exponentially. Inflation theory states that the universe derived from seeds generated during the inflationary period by quantum fluctuations, corresponding to Heisenberg's uncertainty principle, only multiplied by the factor of inflation. The fact that it implied the existence of small fluctuations in the temperature of cosmic background radiation meant that the theory was testable. A lot of research was conducted until in 1992, the Kobe satellite not only proved that such fluctuations exist, but they behave exactly as predicted by inflation theory. This research earned the North American researchers George Smoot and John Mather the Nobel Prize for Physics in 2006. So, what caused this inflation? The consensus is that it must have been a phase transition, much like occurs when water turns into ice. When water freezes to ice, it releases its latent energy. A phase transition occurring at the moment of the Big Bang would likewise have unleashed latent energy, thus causing rapid and sudden expansion in the nascent universe. As for now, many different theories are being tested. And if you enjoyed this video, maybe you could give it a like or maybe even a sub. Also, comment below for video ideas. I surely need them. And if you want me to change my style and try to have more humor or any other suggestions, just throw it down there. Anyways, it's my first video and I sure need to learn a lot. Thanks for watching, and yeah, see you next time.